Hello, everybody. Welcome to my lecture 2 of Math 241 Trigonometry with Vectors. Today we will finish up this section 2.3. Last time we have 2.3a, right? We end up there. Today we will finish up that section and then we will go to 2.4 and then 1.2. Now, 2.3b is the continuation of that solving triangles. Okay, so triangle in 2.3a we solve easy triangles. Now today we will do harder one. Now let's go on with example 3 from our textbook. Example 3 of our textbook. Let's see some screenshot. So we have this situation here. Let me enlarge that a bit. We have this diagram. Okay, and the question is to find x. Find x. Now, this question seems to be difficult because you have too many things at once. One of the way for us to solve geometry problems, in this case trigonometry problems, is our ability to divide and conquer. Like you break the picture, dissolve the picture into simpler diagram, simpler picture. So in this case, I'll draw the right triangle first. Okay, so the right triangle we have there. Okay, we have 35 degrees angle. Right, this is angle A. This is right angle at D, and the vertex C is the center of the circle. Now notice that the radius of the circle is 18. Now the hypotenuse, you have vertex A and then point B somewhere in between, which is the intersection of the hypotenuse and the circle, center C, right? Now notice that because B is on the circle, then BC is the radius, is right? That's the radius. This is 18 here. Let me mark it. This is 18. And the one that we need to solve is this guy, X. Okay? We need to solve for that X. Now, what connects, what relates this side 18, angle 35, and side AC? What trig function connect those? The answer is sine function, right? Sine 35 degrees equals to the opposite 18 over the hypotenuse, x plus 18. Right? Then once we can solve this, we get our x. Okay. Now let's start. What do we do here? We multiply both sides by the LCD x plus 18. Don't forget to use parentheses. X plus 18 sine 35 degrees equals to 18. X times sine 35 degrees plus 18 sine 35 degrees equals to 18. And then I subtract both sides by 18 sine 35 degrees. So don't forget the degree signs. So 18 minus 18 sine 35 degrees. And then we divide both sides by sine 35 degrees. Then from here, you use your calculator. From here, you use your calculator. Oh, there's actually another way to do it. Let me give you another alternative. After I multiply by the LCD, okay, I can divide by sine 35 degrees first. So x plus 18 equals to 18 divided by sine 35 degrees. Then x equals to 18 over sine 35 degrees minus 18. Okay, whichever you think is easier to solve. Okay, now next, then I need to use calculator to solve this. Give me a second. I use my calculator. You use your calculator also. Okay. Let me compute the one in blue first. Okay. So 18 divided by sine 35 degrees. Hold on. Yeah, make sure it is in degree. 18 divided by sine 35 degrees. That is 31.38204. Always five decimal places. Okay. And then subtract it by 18. That will be 13.38204. If you use the blue one. Computational wise, seems like the blue one is easier. Now, if I go back to my work earlier, the first one, then on the top I have 18 minus 18 sine 35 degrees. I get 7.675624 divided by sine 35. Sine 35 degrees. That is, oops, I'm sorry. I get x equals to 13.38204. Yeah, we get the same answer if we have 5 decimal places. Okay, that's for number 3. Now let's take a look at number 4. Let's take a look at number 4. Example 4. Let me do the screenshot again. Yeah, this is our examples from our textbook. Now, during our class time or in other time, I will try to have lecture videos, supplemental lecture videos where I do more problems from our exercise set. Okay, but for now, we will stick with these examples. Actually, it's sufficient. These examples are sufficient. You need to do more exercise, of course, right? Example 4 from our textbook. We have this diagram where we need to solve for x. Okay, again, we are dealing with right triangles. So if you have diagrams that is complicated, try to break them up into smaller right triangles, simpler right triangles. So the first one I can show you here is ACB, triangle ACB. Triangle ACB, right angle at C, right? Okay, and then BC is H. AC, it's not 32, not 32. AC is 32 plus X. Now think about it. Part of that is 32. This is 32, right? Up to D is 32. And then from D to C is X, right? This is 32. And this is X. Now, the angle A is 38 degrees. Maybe I write that 32 underneath. That 32 is here. Okay, Now the angle is 38 degrees. That's the first part, the first triangle. The second right triangle is triangle DCD. I want to use DCB, approximately the same height. Well, I mean, it's supposed to be the same height, right? Okay, oops. C here, vertex B here, and then this is vertex D. The angle is 54 degrees. Now, notice that these two triangles share the same height, h. Okay, now that will be our bridge between these two triangles later on. The adjacent of that 54 degree, however, is x. Okay, now then let's set up the equation. In the first big triangle, notice that the one that relates the h and 32 plus x and 38 degrees, the ones that relates these three quantities is the tangent function, right? So tangent of 38 degrees equals to h over 32 plus x. So later on, our h will be 32 plus x times tangent 38 degrees multiplied by the LCD, right? Now, the second triangle, the slightly smaller triangle, however, we have tangent 54 degrees equals to h over x. So you have to memorize what relates the opposite and adjacent and that angle. Okay, you need to know right away at this point, oh, that's tangent. Now, therefore, the h is equal to x times tangent 54 degrees. Now, this h here, the height, are being shared, both of them side BC, right? So we can equate them each other. We can equate them to each other. So we have 32 plus x times tangent 38 degrees. That's from the first equation, right? This is equal to h, right? But this guy also equal to h. Okay, equals to x times tangent 54 degrees. Now we will solve for x. The way we do it, I will distribute tangent 38 degrees. Again, don't forget the degree sign though. Okay. In chapter 3, you will see without the degree sign, it means something totally different. And then from here, I will collect the x terms on the same side. I will subtract by x tangent 38 degrees. 32 tangent 38 degrees equals to x times tangent 54 degrees, already on the right hand side, minus x tangent 38 degrees. Now, the key step is actually factoring this x. We factor this x, the common factor, right? 54 degrees minus tangent 38 degrees. That is equals to 32 tangent 38 degrees. And then we divide both sides by the guy in the grouping. We divide 32 tangent 38 degrees by tangent 54 degrees minus tangent 38 degrees. Okay, now then from there we use our calculator. On the numerator, we have 32 tangent 38 degrees. Now, please use your calculator. Please confirm that you get the same number. If you have different numbers, very likely because your your angle is still in radian measure. You need to change that into degree measure. Tangent 54 degree minus tangent 38 degrees. I get 0.59509.6. This is 6 decimal places, but we try our best not to do too much rounding before the final answer, 5 decimal places. Okay, so if you can write more than 5 decimal places before your final answer, please do. And I have 25.00114 divided by that answer. I get x equals to 42.01192. Okay, now that's for example 4 in this 2.3. Okay, we draw the boundary between those two examples. So earlier questions, you can use either the black one or the blue one, either way. Okay, now from this section, I would like you to attempt, try suggested homework from here. Section 2.3, second part, we already have suggested homework from part A, right? From number 35 to number 47. Just do the odd ones. Okay. Now, this is for 2.3 second part. Now, let's go on to section 2.4. Okay, let's go on to section 2.4. In this section 2.4, we apply more the ideas that we learned into applications. Basically, we start dealing with real life problems here. Okay, now I will skip those problems with the bearings or with the north-south thingy. Okay, I will use from these sections 2 new definitions. So section 2.4, real life applications. I will use 2 new definitions that we use a lot actually in math. The first one is the phrase angle of elevation. Angle of elevation. Angle of elevation is the angle measured from horizontal going up. To illustrate that, let's say you have this horizontal line. Okay, now angle of elevation is the angle that you measure up from that horizontal line, okay, horizontal direction. So this is what we call angle of elevation. Coming from the word elevate, from horizontal. Okay, now the second one, very similar to that, is called angle of depression. That is the angle measured from horizontal going down. To illustrate again, let's say you have this horizontal line, then angle of depression is the angle that is formed from that horizontal going down. Okay, this is angle of depression. Okay, with these two definitions, let's start applying what we learned into real life. Okay, I'll start with, see my notes, I will start with example 1. I quote from our textbook again, give me a second. Suppose we have this situation here. Now, of course, when you see a graph, try to redraw it though. That way you can see more details. Okay, don't just look at that. Try to redraw it. Try to redraw it. Okay, so this is our example 1. The one in question is to find the x and the y. Find the x and the y. Okay. Now it is said, if you read the question in the book, it is said that we have an isosceles triangle. Isosceles triangle means a triangle with two equal or two congruent legs. Like in this case, these are the two legs that are congruent, both of them 24. Okay, now, we call that isosceles triangle. Isosceles triangle. That is a triangle with two congruent sides. Consequently, if you took geometry before, if you have two congruent sides in a triangle, then you must have two congruent angles too. The opposite angles must be congruent. Okay, because the side here is congruent to this side here, then the opposite angles must be congruent. Okay, now let's come back. What we need to do is to compute the x and therefore the y. Now let's redraw it first. Okay, I will draw this triangle. We have the congruent sides to be 24, right? Then this is a right angle, this is x, and this is y. The angle we have here is 52 degrees. Now, then what is x? What is y? Let's do x first. What relates x and 24 and 52? What trig function relate these three? Of course, when I say which trig functions, I'm referring to the primary one because that's what we have in our calculator. Okay, so what trig function relates x, 24, and 52 degrees? That is sine function, right? Sine 52 degrees equals to x over 24. So x will be 24 times sine 52 degrees, right? Okay, 24 sine 52 degrees. That is 18.9 91226. Now, moreover, what relates the y in 52 and 24? Y is the adjacent, right? 52 degrees and 24 are the angles and hypotenuse 24. So the trig function relates those y 24 and 52 degrees is cosine. It's y over 24. So y is equal to 24 times cosine 52 degrees, right? And then I use my calculator. 24 cosine 52 degrees is 14.7758755588. If I round it to 5 decimal places. Okay, now that's for example 1. Let's take a look for example 2. This is where we will use the definition of angle of depression. Okay, let's code the problem. Second. They give us word problems, so we will try to draw or to sketch the situation from these word problems. Okay, a 75.0 foot flagpole. So you have a flagpole. Let's say this is the flagpole. Okay, this is 75.0 feet. Casts a shadow. It casts a shadow. It casts a shadow with length 43 degrees. 43 feet, I'm sorry, 43.0 feet. Okay, now to the nearest 10 minutes, or let's basically we will find the angle. What is the angle of elevation of the sun from the tip of the shadow? From the tip of the shadow, okay, what is the angle of elevation? What is the alpha here? Okay, now then again we think about, okay, what relates alpha and 75 feet and 43 feet? Which trig function? Oh, tangent, right? Tangent alpha equals to 75 over 43. Okay, and apparently here the alpha is an acute angle, right? Now once it is an acute angle, then we can use inverse trig. Inverse trig function, in this case inverse tangent. Inverse tangent of 75 over 43. Okay, tangent inverse 75 over 43. Now, if you have issue on how to use your calculator and get this number, make sure you ask me. Okay, don't forget to use the degree sign. Now, to answer that question, Thomas, what happens if I want to change this to the nearest 10 minutes? Actually, how about challenging ourselves? Can we change this to DMS style? To DMS style. This is the decimal degree, right? Okay, this is the decimal degree style. How do we find the degree minute second style? Well, okay, so what we will do is, maybe I write it to convert to DMS. What I do is I take the 60 degrees plus multiply that 0.71729115 degrees times 60 minutes. I get 60 degrees plus 10.37492 minutes. Okay, so to answer this question, we are actually done. If you want to round to the nearest 10 minutes, the answer will be 60 degrees, 10 minutes. But I want us to challenge ourselves a bit further. Can we write that in DMS, right? Degree, minutes, seconds. So we already have the degrees, we already have the minutes, plus 0.37492 minutes times 60 seconds. So subtract that 10, I get only 0.737492 multiplied by 60, I get 22.49524 seconds. Now, if I round it to the nearest second, that will be 60 degrees, 10 minutes, 22 seconds. Okay, now that's for our example 2. Now, let's see our example 3. Again, I try to go over problems in our text, examples in our textbook, and then in my supplemental video later on, I will try to do problems from our textbook. Okay, so here's what we have for example number 3. A man climbs 213 meters up the side of a pyramid and finds the angle of depressions to his starting point is 52.6 degrees. Okay, so let's imagine a pyramid first. Oh, let's use this one. Okay, so suppose this is a pyramid. Okay, now this person actually climbs 213 meters up a pyramid. Okay, the side of pyramid, and find the angle of depression from that pyramid here. Okay, the angle of depression. Remember, depression means from the horizontal going down. Okay, angle of depression is 52.6 degrees. Now the question is, how high off the ground is he? So how high off the ground is he? This is the height. Okay, now think about this triangle here. What relates the height, which is opposite of 52.6 degrees, and 213 meters, which is the hypotenuse, and 52.6 degrees. Okay, what trig functions relates that? Yes, that's the sine function. The opposite of 52.6 degrees equals to, right? Sine 52.6 degrees is the opposite h over the hypotenuse 213, right? So the height will be 213 sine 52.6 degrees. Now then from there we use our calculator. 213 sine 52.6. The height is 169.21031 meter. Okay, now that's for example 3. Now I would like to do more problems from our textbook. I will see problem number 2 from our textbook. Let me go to the book. Problem number 2. So if you have your book with you or the PDF file, please open your textbook, take a look on number 2. I will put it here. Okay. Problem number 2. An equilateral triangle has an altitude of 4.3 inches. Now, what is equilateral triangle? A triangle is equilateral if the length of all three sides are congruent. The length of all three sides are congruent. Now, consequently, because the length of three sides are congruent, then all three angles must be congruent also. Now, we know that the sum of the angles in a triangle, the interior angles of a triangle is 180 degrees, right? Now, three of them are equal. So if we divide by 3, each of them will be 60 degrees. Okay, each of them will be 60 degrees. Okay, now it is said here that the altitude, which is the height from the base, okay, the altitude is 4.3 inches. Now find the length of the sides. We know the angle implicitly. They don't give us explicitly, but knowing that it is an equilateral triangle, then the measure of each angle must be 60 degrees. Now, choose one right triangle to work with. I will choose the right triangle on the left-hand side. Okay. Suppose that's the one on the left-hand side, right? Okay. Now, we know that this is 60 degrees. This is a right angle. This is 4.3 meter. Oh, I'm sorry, inches. And we need to find the length here. Let's call that the side S. Okay, the side S. Now, what is S? Now, again, then we think, oh, what trig function relates the opposite of that 60 degrees with 60 degrees with the hypotenuse? It's true. That's the sine. Sine 60 degrees equals to 4.3 inches over the side. Multiply both sides by sides. And then divide by S. So S equals to 4.3 inches divided by sine 60 degrees. Now you can use your calculator for this. Give me a second. Now you can use calculator for this already, right? But because this is a special angle, sine 60 degree is one of the trig functions with special angles, then I would like you to try doing this with the exact value. Now 4.3 inches divided by sine 60 degrees. Sine 60 degrees radical 3 over 2. Okay, now of course, again, you can just use calculator earlier, right? But suppose the question wants you to answer in exact answer, not approximate, no rounding. Then how will you work that out? Okay, this is the way you do it. Okay, if you want the exact answer. Now from here, I will multiply the top and the bottom because this is complex fractions, right? I multiply the top and the bottom by the LCD 2 such that the denominator becomes radical 3 only, right? The 2 cancels. On the numerator, we have 8.6 inches. Okay, going further, multiply by radical 3 on the top and the bottom, we get 8.6 radical 3 over 3 inches. Now, this is the exact solution. Okay, we say that here explicitly, this is exact solution. If you are going to trigger pre-calculus and calculus later on, you need to get used to this style. Okay, instead of writing your answer always in decimal with rounding, get used to write your answer in exact form. Okay? Which means no rounding here. We don't do any rounding here. Okay, once you go to pre-calculus and calculus, that's the answer you will see at the back of the book. Now, of course, like what I said earlier, if you are happy enough with rounded solution, then you do 4.3 divided by sine 60 degrees. Okay, you will get this is equal to This is equal to 4.96521 inches. Now, this is an approximate solution, not an exact solution. Okay. Now, the thing is, in math, if you already have approximate solution and you use that result for the next computation, you use that result, the one with rounding error in the next computation, you eventually have what we call compounded rounding error, which basically means you have rounding error that actually accumulates. If your computation too long, you may end up with more rounding error. Okay. Next one, I want to work out. Let's try number 4. It's an interesting question, actually. Number 4 from our exercise set. Okay, the diagonal of a rectangle is 348 millimeters. Oh, let's draw a rectangle first. A rectangle. A rectangle looks like this. That's a rectangle. Okay, the diagonal, let me use different color. The diagonal is 348 millimeter. Okay, while the longer side is 278 millimeter. Find the shorter side of the rectangle. So this is the shorter side. Let's call that B, right? And the angles the diagonal makes with the sides. There are actually 2 angles. This one here, which you will see this angle A here is congruent to this angle here. Notice that if you see from that angle of elevation and angle of depression, right? Angle of depression here is the same to angle of elevation underneath. Okay, now the other angle is this angle, let's call it angle beta here. Okay, which is congruent to this one. Now notice that angle alpha and angle beta are congruent. Let me call this side H instead, the height. Okay, now if we redraw this equation, notice that we actually have a right triangle this way, right? Okay, we have a right angle here. This is 348 for the hypotenuse, 278 for one of the leg, and this is the height, right? Now to find the height, we can just use Pythagorean theorem. Okay, to find the height, we can just use Pythagorean theorem. So 278 squared plus h squared equals to 348 squared. H squared equals to 348 squared minus 278 squared. Now then from there you use your calculator. Okay. Now I will show you, well, if you have calculator, of course, it is easy to compute 348 squared minus 278 squared. This is 43,820. So the h, the height, will be the square root of that, which is 209.33227 millimeter. Okay, if you use calculator. Now, Thomas, what happened if you don't use calculator? Now, then here we review a little algebra. Notice that what we have up there is actually difference of squares. So if you try to compute it by hand, you can do difference of squares, right? A plus B, A minus B, if you remember that. A squared minus B squared is A plus B, A minus B. I wonder if you remember that. Okay. A squared minus B squared equals to A plus B, A minus B. So instead of squaring them, you change that into the product of sum, which is 626 times the difference, which is 70. Okay. Now then, if you happen to have nice numbers, that would be easier to compute, but well, you still have calculator. Okay, so h equals to the square root of 626 times 70. So this is not decimal point. Okay, this is multiplication sign. You will get the same value, okay, if you use this method. Okay, if you have calculator, don't worry about it. Now then, the angles, let's use this one here, angle alpha, what relates to 78 and 348, that is cosine, right? Cosine alpha equals to 278 over 348. Notice that alpha is an acute angle. If it is not an acute angle, then we cannot, for now, we cannot use inverse cosine yet. Okay, we only learn to use inverse sine, inverse cosine, inverse tangent for an acute angle. So make sure that you have an acute angle before you use this for now. So I use my calculator. Cosine inverse of 278 divided by 348, I get 36.97952 degrees. Now, angle beta is the complement, right? Angle beta is the complement, so beta must be 90 degrees minus alpha, right? That's the complement angle. Use your calculator, you will get 53.02048 degrees. Okay. And you can see that alpha and beta are complementary. This alpha and beta are complementary because if you see this beta here, the same to this beta, notice that these two angles, alpha and beta, form a 90 degrees, right? So that confirms that the sum of two non-right angles in a right triangle, so you have a right triangle here, right? You have a right triangle here. Two of the non-right angles, when they add up, they add up to 90 degrees. Okay, they are complementary angles. Okay, that's for number 4. Now let's do one more problem from here. I will go ahead with question number 24. Let's see, question number 24. The reason I choose this question because it's word problems, and when it comes to word problem, please be patient with yourself in reading it. You need to get used to it though. Okay, you need to get used to it. Okay, two people decide to find the height of an obelisk. So let's say you have an obelisk. Obelisk looks like what, like this maybe? Approximately. They position themselves 2 feet apart in line with and on the same side of. So on the same side of that obelisk, in line, 25 feet apart. So this is 25 feet apart. Okay, on the same side, okay, of the obelisk. If they find the angle of elevations from the ground, where they are standing to the top of the obelisk are 65 degrees and 44 degrees. So angle of elevations will be this angle here and this angle here. Now, can you tell which one is 65 degrees, which one is 44 degrees? 65 degrees is larger, right? Okay, now, and you see this angle is actually bigger. So this is 65 degrees, this is 44 degrees. Okay, Now, the question is, how tall is the obelisk? What is the height? What is the height of this obelisk? Okay. Now, notice that these heights are being shared. Okay. And in the right triangles, let's draw the big one first. This is 44 degrees. This is the height, but the length here is 25 plus, let's call that x. If we call this x. Okay. While the other right triangle with 65 degrees, this is 65 degrees, this is h, right angle x. So what we need to do is to equate this h. Let's see. From the first triangle, we see that tangent 44, why tangent, Thomas? Well, take a look on the picture. What relates 44 degrees with the h, which is the opposite, and 25 plus h plus x, which is the adjacent. That's tangent, right? While on the second triangle, tangent 65 degrees equals to h over x. Okay, now then, to solve this, I solve for h for each of them. So I have 25, I'm sorry, I have 25 plus x times tangent 44 degrees equals to h, and x times tangent 65 degrees equals to h. Now, notice that both of them equal to h, right? So I can equate them together. Let me continue here. So this is the one equals to h. This is also equal to h. Okay, so let me continue here. 25 plus x times tangent 44 degrees equals to, that's the one in yellow, equals to x tangent 65 degrees, the one in blue. Now we will solve for x here. We will solve for x here. We did this routine earlier, okay? I will do it again, don't worry. But you need to get used to solve these kind of equations, okay? We'll solve for x here. And then to find the h, which is our main goal, I will plug this x into this x tangent 65 degrees. And then we find the h. Actually, you can put it here too. You can put it here too to find the height. But I think the one in blue is simpler. Okay, now let's start the computation. Go back, erase this. Yeah, I tried to explain to you the what we are going to do. So we'll solve for x first. Once we get x, we will put that into the blue one to solve for h. Okay, so 25 tangent 44 degrees plus x tangent 44 degrees equals to x tangent 65 degrees. I subtract both sides by, I basically move the x term to the right hand side. So I subtract both sides by x tangent 44 degrees. And then factor the x. You know where I'm going here. Now, once I subtract them, I will divide both sides by that group. It's 25 tangent 44 degrees divided by tangent 65 degrees minus tangent 44 degrees equals to x. Okay. Now, once we get that x, then we will compute that, plug that into either one, the yellow one or the blue one. I think I will put it in the blue one. Okay. Let's compute that first then. That's 25 tangent 44 degrees divided by parentheses tangent 65 degrees minus tangent 44 degrees. Now make sure you do this on your own to get this number. If you don't get this number, then something wrong with the way you type your calculator. Okay. Now, notice that this 20.480020 already have rounding error, right? Okay. When you multiply this x, which is 20.480020 by tangent 65 degrees, you may have compounding rounding errors. Okay. You may have compounded rounding error. I will continue multiplied by tangent 65 degrees. I will get 43.91954. That's the height. Oh, by the way, what's the unit? Feet. The unit is in feet. So make sure we write the unit here in feet. This is also in feet. Okay. If you want the exact value, just keep that x, multiply right away by tangent 65 degrees. Okay, 25 tangent 44 degrees multiplied by tangent 65 degrees over tangent 65 degrees minus tangent 44 degrees. That's equals to the height. Notice that this is my x. This is my x multiplied by 65 degrees. Okay. Now that is the exact solution. Okay, but the approximate solution is the one here. This is approximate solution. Okay. Now, usually in my test, I want you to write your answer in exact solution and in approximate solution. Now, if I don't say is it exact or approximate, then you can answer that in the approximate solution. But don't forget, always round it to 5 decimal places. Okay, always round it to 5 decimal places. Okay, this is basically what we need to learn from this section 2.4. Let's see, suggested homework will be section 2.4, number 1 to number 11, number 15, 23, 25, and then 29. Okay, that's for homework, suggested homework from 2.4. Please try to work this out. Okay, and feel free to come to my class time during my office hour maybe, or class time, and ask me questions. Okay, it's better for you to ask me questions and then learn instead of like not asking at all and never learn. Okay, our goal, our purpose in this class is to learn, right? Okay, now then let's go on to section 1.4. I'm sorry, 1.2. Oops, I need to delete this. Section 1.2. Okay, section 1.2, that is angles in coordinate system. Right. There are some terminologies that we need to learn here. Actually, it's more about terminologies. This section, very, very less computation. It's more about terminology. First one, we will talk about distance formula. Suppose on a coordinate system, x and y, we have two coordinates, call that coordinate, let me use different color, x comma x1, y1, and another coordinate x2, y2. And we want to find out the distance between these 2 points here. How long is this line segment? The way we do that, if you took algebra 2, you know how to do this already. Okay, but the idea behind what we do is actually Pythagorean theorem. We try to find the horizontal distance, right? See, this is x1, right? This is x1, this is x2, right? Okay, so the distance, horizontal distance, the horizontal length here is x2 minus x1, while the change of the height is actually the change of the y's, right? This is y1, this is y2. So the length here is y2 minus y1. Okay? So the distance d is the hypotenuse of these two legs of a right triangle. Okay, so d squared, let me change the color. So the distance squared equals to x2 minus x1 squared plus y2 minus y1 squared. Okay, actually, if you have problems, like let's say you are given two coordinates and find the distance, I tend to use this formula first, and then after you're done with the numbers, then you do square root. Okay, some textbook, including our textbook, however, apply square root right away into the formula, which is also okay. But in my opinion, it is actually more convenient to use the above formula, plug in numbers, and then you do the square root. Okay, suppose for example, if we want to find the distance between let's say find the distance between find the distance between negative 3,5 and what is good 1 comma negative 7. Okay, now what I meant earlier is instead of using the square root version, I do the square version. D squared, which is the distance between these 2 points, equals to x2 minus x1 squared plus y2 minus y1 squared. Okay, I will compute the numbers first. And then after I'm done with the computation, this is 4 squared plus negative 12 squared. This is 16 plus 144. That's 160. Huh? Okay, that's d squared, right? So the d must be the square root of that 160, which happens to be 16 times 10, right? That's square root of 16 times 10. Oops, 16 times 10, which becomes square root of 16 give us 4. 10 is not a square number, so we leave it inside the square root. Okay, now This is what I meant by simplifying. Simplify to be 4 square root of 10. You have to simplify. You don't have to compute into decimal. Okay, this is the exact solution. This is the exact solution. Okay, and the approximate solution will be square root of 160. That is 12.64911. This is the approximate solution. Okay, now, so please start to differentiate what we meant by to compute. Okay, to simplify. Simplify means you still write that in exact solution, but in simplified form. In this case, 4 square root of 10. Okay, now that's distance formula. From distance formula, we come up with the equation of a circle. A circle is a collection of points with equal distance from a fixed point. Okay, now the equal distance here, we usually call that radius. Okay, and the fixed point here, we usually call that center. Okay, so let's take a look. If you have a circle, right? If we have a circle, this is circle enough, right? Then this is the center, let's say. This is the radius. Any point you pick on that circle will have equal distance from the center. Okay, that's a circle. Now, suppose the center is, suppose the center of a circle is h comma k with radius r. Then the equation of that circle must be, now think about this. Think about this. Let's say the center is h comma k. H comma k. Okay, and all this point has coordinate x comma y. So however you choose this coordinate x comma y, as long as it is on the circle, then the distance must be r, right? Okay, so r squared is equal to x minus h squared, okay, x2 minus x1, right, plus y minus k squared. All of a sudden, we have equation of a circle. This is the equation of a circle. Okay, so for example, suppose we have call that example 1. Suppose we have the center is 3 comma negative 4 with radius equals to 7. Then the equation must be x minus h squared plus y minus -4 squared. When you subtract by negative number, you add, equals to 7 squared. Okay. If we know the center and the radius, you get the equation. In fact, how about going backward? Suppose we know the equation. From the equation, can we tell the center and the radius? Suppose the equation is x plus 2 squared plus y minus 7 squared equals to, let's say, 12. Then from there, we see the center is -2, right? And the radius is square root of 12. See, the position of this 12 is r squared, just like this 49 is r squared, right? Okay, so the r is square root of 12, which simplifies to be, that's, the 12 is 4 times 3, so it becomes 2 square root of 3. Okay, now, unit circle centered at origin, unit circle centered at origin. We will use this a lot, especially in chapter 3. You call unit circle means, when we say unit circle, it means the radius is 1. Okay, and if actually there's a convention, there's a tradition in trigonometry or even in math in general. When we say unit circle, it actually refers to unit circle centered at origin, unless we specify the center somewhere else. But if somebody just say, oh, consider a unit circle, it is actually referring to a unit circle centered at origin. Okay, center at origin means the center is 0, 0. Okay, now the equation of unit circle centered at origin is x minus 0 squared plus y minus 0 squared equals to 1 squared, which simplifies to be x squared plus y squared equals to 1. Now remember this equation very well, because we see that a lot. Okay, second terminology. And the next one here is extremely important. Please remember this. Okay, part B. Let me put that red mark in order. Angle in standard position. An angle is in standard position if its initial side is positive x-axis with vertex at origin 0, 0. Okay, and measured counterclockwise to its terminal side. Now, this is what I meant. Suppose you have coordinate system, right? And this is our positive x-axis, right? Now, that angle is in standard position if you have a terminal side from the origin, right? And it is measured from positive x-axis counterclockwise to that terminal side. Now we say this angle in standard position if it is measured this way. Okay, let me say it again. An angle is said to be in standard position if the initial side is positive x-axis with vertex at origin and measured counterclockwise to its terminal side. Now, why is this so important? Because from now on, every angle that we apply to coordinate system, unless otherwise stated, must be in standard position. Okay, so for example, suppose I said, oh, consider an angle in coordinate system, the angle 30 degrees. Now, you don't need to ask further 30 degrees from where, in which direction. No, once we say 30 degrees on coordinate system, then it must be in standard position, 30 degrees like this. Okay, we don't need to say further, oh, from the positive y-axis or from the negative x-axis. No, if we just say 30 degrees in coordinate system, if I don't say anything further, then it must be in standard position. This is why this idea, this concept, this terminology becomes very important. Okay, becomes very important because if you don't know this idea here, and somebody say consider 30 degrees, you wonder what 30 degrees? From where? To which direction? Where's the vertex? You must have that question. Okay, but once you know that angle in standard position means this, and in math, especially in trigonometry, when we mention an angle on coordinate system, then it must be that angle must be in standard position. Okay, it is measured from positive x-axis, measured counterclockwise against the direction of our clock. Okay, so when we say angle 90 degrees, for example, when we say angle 90 degrees, for example, we don't need to say too much. Angle 90 degrees must be this one. Okay, angle 100 degrees must be this one. We don't need to explain further, oh, from positive x-axis going counterclockwise. No need. Okay, because otherwise stated, it must be in standard position. Okay, so Thomas, what happened if we measure that clockwise, the same direction with the clock? Then we will have negative angle. Okay, suppose we have something looks like this. Okay, then this angle is called negative 45 degrees. Okay, the negative for that angle means we go clockwise. Okay, now next, going back to that idea of angle in standard position, then you will see the following. The angle in quadrant 1, if the terminal side ends in quadrant 1, if the terminal side ends in quadrant 1, it means the alpha must be between 0 degree to 90 degrees. Okay, the notation we use, oh, by the way, this is the way we say that the angle is an acute angle, remember? Okay, acute angle if it is positive but less than 90, right? Okay, we can also call this angle in the first quadrant. That is the notation. Okay, angle in the second quadrant, oops, no. angle in second quadrant if the terminal site is on the second quadrant. Notice that the angle, therefore, this angle, therefore, is greater than 90 degrees, right? But less than 180 degrees. If you remember from our last lecture, lecture 1, we call this angle an obtuse angle. And the alpha is denoted to be in quadrant 2. Okay? If the terminal angle ends in quadrant 3, then the angle must be more than 180 degrees, but less than 270 degrees. We say that angle is in quadrant 3, this element of quadrant 3. And finally, the angle is, the terminal site is in quadrant 4. The terminal site is in quadrant 4. Then the angle must be more than 270 degrees, but less than 360 degrees. We say that angle to be in quadrant 4. Okay, those are angles in standard position. Next, the phrase or the word coterminal. This last one, coterminal. Coterminal angles. Coterminal angles refers to angles in standard position with the same terminal sites. Terminal site. So if you have the same terminal site, okay, if you have the same terminal site, you may have different angles associated to that terminal site. Let's say, for example, this guy here. Okay, now of course, this is one of the angles, right? Call that angle alpha. Now I want you to realize that if you add 360 degrees to this alpha, if you add 360 degrees to this alpha, okay, you will get the same terminal site, right? Now you call that co-terminal angle, alpha plus 360 degrees. Okay. Oh, in fact, you can subtract by 360 degrees too. So if you go backward, right? If you go backward, this is also a coterminal angle. Okay. In fact, this is actually 300. This is actually negative. Hold on. This is alpha minus 360 degrees. Alpha minus 360 degrees. Let's do an example. Maybe an example will help us better. Suppose you have 60 degrees here. Suppose you have 60 degrees here. Okay, then 60 degrees is coterminal. I use that notation for coterminal with, if you add 360 degrees to it. So 420 degrees is coterminal to this 60 degrees. Okay, so imagine if I go this way, 360 degrees plus 60 degrees, more than one round. Okay, they are coterminal. Okay, now we can also see instead, suppose if I go backward, negative 300 degrees, right? Okay, negative 300 degrees is coterminal to 60 degrees. Now that negative 300 degrees comes from 60 degrees minus 360 degrees. Okay, so these three angles here are coterminals. Okay, so we have infinite, from here you see that we have infinitely many coterminal angles with the same terminal sides. Okay, like 60 degrees is congruent to, I'm sorry, I should say 60 degrees is coterminal from what we saw earlier, 420 degrees, which is coterminal to negative 300 degrees, which is coterminal to negative 660 degrees if you subtract another 360. Okay, or coterminal with 780 degrees if from 420 you add 360 degrees. If you keep on adding 360 degrees to that angle, you get the coterminal. If you keep on subtracting 360 degrees, you get another coterminal. Okay. Now let's do some, I think those are actually pretty clear. So you can just go ahead with doing some suggested homework from here. Suggested homework is from this section 1.2. I would like you to try number 39 to 49 and then continue with number 59 to 69. Just do the odd one so that you can check the answer with the back of the book. Now, in our next meeting, I will continue in my next lecture, lecture 3, I will continue with section 1.3 and then 1.4 and then 1.5. Okay, so long.